right, welcome to our final uniform motion video. This video is on opposite direction travel problems. So let's go ahead and look at question number 1. Dylan and Lucas leave their uncle's house traveling in opposite directions on a straight road. Dylan travels 15 miles per hour faster than Lucas. After 3 hours, they are 225 miles apart. Find Dylan's rate and Lucas's rate. Okay, the first thing I'm going to do is draw a picture, and you can draw this somewhere on your paper if you'd like, but make sure you still leave room to do like the equation and all of that. So here is their uncle's house, and then it says Dylan drives 15 miles per hour faster than Lucas, so he's going zooming in this direction, okay? And Lucas is traveling in the opposite direction. So he also leaves the uncle's house, but he's going this direction. After 3 hours, they are a total of 225 miles apart. So from here to here is 225 miles. Now, actually, let me make this picture a little bit more accurate. I'm going to make Lucas's line a little bit shorter. And, oops, sorry, not that short. The reason I'm making it just a little bit shorter is because if they're both traveling for 3 hours, but Lucas is traveling slower, Dylan's traveling 15 miles per hour faster, Lucas won't have gone as far. But anyways, from here to here, after they drove for 3 hours, they are 225 miles apart. So that's kind of a picture for our story. All right, let's go ahead and get started by defining our variables. We see that the final question says find Dylan's rate and Lucas's rate. So obviously we are doing something about rate. So I'm going to say x equals, and I see something about Dylan. It says Dylan drives 15 miles per hour faster than Lucas. So I'm going to make x Lucas. He is more mysterious. So x is Lucas's rate. And then Dylan drives 15 miles per hour faster. So we're going to say x plus 15 is Dylan's rate. Okay, now let's go ahead and fill in our information on our table. So the first person that we are going to talk about is Lucas. And what we know about Lucas is that his rate is x. Okay, and then we have Dylan. And Dylan's rate is a little bit faster. It's x plus 15. Now, for the time, this can be confusing for people sometimes. But it says after 3 hours, they are 225 miles apart. That means they were both traveling for exactly 3 hours. So we can write that in for both of them. And then again, distance is always rate times time. So my distance for Lucas is going to be 3x. And my distance for Dylan is going to be 3 times the quantity x plus 15. Now I need to write an equation. Well, from the picture that I showed, I know that Lucas's distance, 3x, plus Dylan's distance, and let's actually draw another quick sketch. So here we are at the uncle's house. Lucas goes this way for 3 hours. Dylan goes a little farther because he went faster for 3 hours. We know that their distances, the red and the blue, are going to combine to be a total of 225 miles apart from each other. So we can go ahead and write an equation where we're adding up this chunk and this chunk. So 3x plus Dylan's distance, 3 times x plus 15, is going to equal a total of 225 miles. That's how far apart they're going to be. So now we can just solve this multi-step equation using the distributive property. 3x plus 45 equals 225. 6x plus 45 is 225. Subtract my 45. And I get 6x equals 180. If I divide by 6, I get x equals 30. Now we're not done because the question says what is Dylan's rate and what is Lucas's rate. So I definitely need to put some labels here. I'm going to say Lucas, 30 miles per hour mph. And then Dylan was 15 miles per hour faster. He's 45 miles per hour. Now, I definitely want to check my work here because these problems can be a little bit confusing. In order to check my work, what I'm going to do is plug in x here and plug in x here and make sure that that would in fact add up to a total of 225 miles. So 3 times 30. So Lucas would have drove 90 miles. And then Dylan was 3 times 30 plus 15, 3 times 45. So we find out that he has drove 135 miles. So if I add these up, 135 plus 90, I do find out that that is 225. So I got the correct answer of 30 miles per hour and 45 miles per hour. Okay, on to the next question. Minnie and Mickey leave Hollywood traveling opposite directions on a straight road. Minnie drives 12 miles per hour faster than Mickey. After 2 hours, they are 176 miles apart. Find Minnie's speed and Mickey's speed. Okay, for this one, since it's so similar to the previous problem, I would like you to try this problem on your own and then press pause on the video and then restart it when you're ready. Okay, so we should first define our variables. I see something about Minnie. It says Minnie drives 12 miles an hour faster than Mickey. So x is actually going to be Mickey's speed. And then x plus 12 is going to be Minnie's speed. So it doesn't matter which person you put first. You could put Mickey or you could put Minnie. I'm going to go with Minnie. And Minnie's rate is x plus 12. And her time is 2 hours. It told me that after 2 hours they were so far apart. So her distance is going to be 2 times the quantity x plus 12 because distance is always rate times time. My next person is Mickey. And Mickey's rate was just regular x because we didn't know anything about Mickey. He also drove for 2 hours. Both of them did. So Mickey's distance is 2x. So when I go to write my equation, I kind of have to visualize what's going on in the story. They are leaving Hollywood. So there's an H for Hollywood. Minnie is going this way. Mickey is going this way. And after 2 hours, they're 176 miles apart. So their distances add up to 176. So I can actually just write an equation. I'll write it with my hand. Okay. So x plus 12, which is Minnie. No, sorry, not that. Erase. Their distances add up to 176, and I'm going to erase this too, actually, just to give us some more space. Okay, so Minnie's distance was 2 times x plus 12, and then plus, because we're adding up Mickey's distance with that, and they're going to set equal to 176. So we've got 2x plus 24 plus 2x equals 176. 4x plus 24 equals 176. Subtract 24. And I'm left with 4x equals 152. And then from there, all I would need to do is divide. So when I divide by 4, I get 38. Now, 38 is x, which is Mickey. But I want to know Mickey's speed and Minnie's speed. So to find Minnie's speed, I would have to add 12. So I know Minnie would be 50. And again, I want to label so that when it's being graded, I can tell which one's which. So Mickey is 38 miles per hour. And then Minnie is 50 miles per hour. Okay, on to the third problem. Zach and Adam live 3 miles apart. They both leave their houses at the same time and walk to meet each other. Zach walks 2.5 miles per hour and Adam walks 3.5 miles per hour. How far will Adam walk before he meets Zach? Now this is a little bit more of a complicated problem because when we solve for x, we're going to need to do something with that. We're going to have to re-plug it back in. But anyways, I'm going to start this one with you, and then we're going to finish it during class tomorrow. So first thing I would do is probably draw a picture. We've got Zach over here, and we've got Adam over here. And they're going to meet somewhere. They're not going to meet directly in the middle, though, because they're leaving at the exact same time. And Adam's walking faster. So Adam's going to get a little more than halfway. And then Zach is going to meet wherever they happen to meet, like right here, where their paths would cross. So this still is an opposite direction problem. They're going, opposite directions are going towards each other. But the one thing that we don't know at all is how long they walked. So we have no idea about the time. So x equals the amount of time walked in hours. Okay, so my first person is Zach. My next person is Adam. We know Zach's rate. It tells me that it is 2.5 and Adam's is 3.5. Now for time, they're walking the exact same amount of time. They might call each other or text each other and say, okay, ready, set, go, we'll meet wherever we meet. And they go walking, and then, so they start at the same time, and then when they see each other, they both stop. So they're both walking for the same amount of time. So both of them actually have x. And then my distance is 2.5x, and my distance here is 3.5x. And now that we have the relate box set up, I think you can probably do the rest on your own. You're going to need to read through the rest of the problem to figure out what you're setting it equal to. But go ahead and try that, and then we will go over it tomorrow. Thanks for watching.